All right, so again, multiplying, dividing decimals. Yesterday we talked about dividing fractions. Do you guys, I hope you do, but let's see. The last class I asked, and they're kind of like blank face, but do you remember when we did a division problem, what your answer meant? Do you guys know how to explain that? So let me give you a hint. Oh, go ahead, Sarah.
Blank many groups of blank goes into blank.
Good, yeah. How many of these groups, how many groups of this number go in the first number? Good, that's exactly it. And that's also going to apply to decimals, because decimals can also be divided, and therefore you can get those same answers. So we're going to start, though, talking with multiplying. And most of you have already done this many, many times. So I'm just going to give you just tips that'll help you to get these more successfully, because it's funny, or it's not funny, it's kind of discouraging when you work out this problem and you were so close, but you got it wrong, right? You missed one little number and it's off. So what's going to help us to avoid it? Well, here for multiplying, it's the placement. The big thing I want you to look out for is the placement of the decimal point in the product. So really, with multiplying decimal numbers, you're not doing much more different than you would with multiplying whole numbers. Except at the end, you got to know where to put that decimal point in your answer, in the product. Okay, so please keep that in mind. And once you get this down, we'll go to the first example. Example 1 on page 295, 1A. All right, example 1A. And let's see how we put this into practice. So I have C equals 3.9 times 8.2. All right, because I want to review also for your quiz, which is coming up on Friday, and it's over lesson 6-1 to 6-5, so today's lesson. But to review, I want to look at this problem, not start working it out right away. I want to estimate an answer. I want to see, can I get an approximate of what this is going to be? So I'm just going to put under here EST, so that's an S, EST, and what's 3.9 about? 4. And what's 8.2 about? 8. So what's your estimate?
32.
Yeah, I would say about 32. Is that your actual answer? No, it's an estimate. So you can do this in your head. You're like, okay, 4 times 8 is about 32. My answer should be close to that. All right. When you are multiplying decimal numbers, do you have to line up the decimal points? No. In fact, with decimal numbers, you don't even have to worry about the decimals until the very end. Okay, so I'm going to write these numbers here. 3.9 times 8.2. Okay, another question I get with multiplying decimals is, which number should I put up top? So which one should I put? Should I put the 3.9 up top, or should I have switched it and put the 8.2 up top?
Really, it's just with whatever one has the most digits. So
okay.
It's fine.
So you mean I can switch them around? Okay, what property says I can switch them around? So let's say this one had more digits. I put it up top. Am I allowed to do that? And if so, why? Commutative property. So I'm going to keep it like this, but could you have done 8.2 times 3.9? Yes. Now, the decimal point's a line. Did I have to do that? No, it just happened to happen. It just happened to be that way in this case, but it doesn't. You don't have to force it. All right, everyone. 9 times 2.
18.
2 times 3 plus 1.
73.
7. There you go. That's right. 8 times 9. 72. 8 times 3 plus 7. That's 31. All right. So 8 times 3 was 24. Plus 7 is 31. Then you're going to add the partial products. So I get 8, 9, 1, 3. And at the very end, that's when you really have to think of your decimal point. So where does, I know where it goes. It should go between the 9 and the 8, right? Oh, why would between the 9 and the 8 not work? Look at my estimate. What do you think? What's wrong with it? Yeah? Oh, duh. It's between the 3 and the 1. I went way too big, right? So 3 and the 1, that would be 3.198. Nope. So where does it go? Between the 1 and the 9. Now, you can use your estimate to help you think that through, or there's a surefire way each time you do it, you got to do this, and that's where the decimal point will go. Does anyone know what to do? You always do this, Rachel.
How many places are behind the decimals for the number?
Okay, so I have 1 here and 1 there, so I have 2 total. So then I start here and go 1, 2. Yep, that's it. So count up how many decimal place values are represented in the 2 numbers, then move it that many times. So I get C is equal to 31.98. Is that pretty close to my estimate? Yeah, it's very close. Okay, so that's my answer. All right. So not too much difficulty. You know what's going to really hinder people from getting these right? I tried to do charades with the last class. It didn't work. But maybe I'll try it out. You know what's going to really hurt you here?
Rushing.
There you go, rushing. Wow. That was good. Are you guys good at charades?
No.
No? Okay. I'm not good either, but you picked it up. The last time I was doing all these motions and no one got it. So finally, thank you, Sarah, for helping me out to not be... Is this recording? Oh, man. Is there a way to edit that out? Swivl, help me out. Yeah? No? Okay, fine. All right, so anyway... The thing that's really going to hurt us is by you're just going to go too fast. And also with division, being too sloppy. Like your numbers are just kind of there. And I've seen this now, and it's sad. This year alone, I've seen about 5 times where I'm helping a student out, and they don't even know what number they wrote down. They're like looking at that number, and like they write down a 6. Wait, what number is that? I think it's a 6. Wait, no, it's an 8. Wait, you don't know what you wrote down? Whose problem is that? Yours. So don't get into sloppiness, because then you can't even read your own writing. That's hard. I don't know how you're going to overcome that other than going a little bit slower and writing neater. All right. B, X equals negative 6.302 times 0.81. Okay. Before I work this one out, you can do this mentally. You can write it down. I'm going to estimate an answer. So what would you round negative 6.302 to? Yep, sir?
Negative 6.
All right, so negative 6 is a good one. And then what about 0.81? Yep, Davis? 1. And what's negative 6 times 1? Negative 6. So that's an estimate. That's about what my answer should be. So these scary numbers with all these decimal place values, they can be a little bit easier to digest or to take in if you estimate. Oh, okay, about 6. All right. Does it matter which one I put up top? Not really, but and I think Josh mentioned this, the one with the most place values are usually the best ones to put up top. I'm not even going to think of the negative number right now. And somebody tell me why I'm not even thinking about the negative sign there. I don't even care about that negative sign because I already know how to handle it right away. Anyone know? Chelsea, want to? What's the sign of my answer without even working it out? What's it going to be? What's a negative times a positive? So I'm done dealing with that negative. It's going to be x equals negative something. So I'm going to work it out. Did the decimal points align? No, they didn't have to, so I'm not worried about that. All right, 1 times 2, everyone.
2.
Yay, 2. 1 times 0. 1 times 3. 1 times 6. All right, good. Place value holder, which I noticed in the last class some of us didn't do that. Don't forget that place value holder. 8 times 2. 16. 8 times 0 plus 1.
1.
Oh, wow. 8 times 3.
24.
8 times 6 plus 2.
50.
Yes, 50. All right, then add the partial products together. We get 2, 6, 4, 10, 1, 5. That decimal point. How many times should I move the decimal from the far right? How many times? 5 times. Oh, yeah. 1, 2, 3, 4, 5. That's how I got that number. 1, 2, 3, 4, 5. Oh. What's my answer going to be here? Negative 5.10462. Okay, that's my answer right here. Negative. Oh, but that's not even close to negative 6, is it?
No, it's kind of close.
Yeah, it's less than 1 away from it, so it's very close. Good. Yep. Yeah, go ahead.
Are we doing like actual or estimate?
Good question. Your answer needs to be the actual. The estimate is for you to be able to look at your actual and see if they make sense. You do not have to do this, but I would recommend you at least try it in your head. It should be about that. Okay. You guys good on those? Not too bad, right? So do you have to line up decimal places when you're multiplying decimals? No. When do you even have to look at the decimal point? At the very end. Okay. Let's look at something in between multiplication and division. We already mentioned some of these. Let's just do a little quick review. The properties of multiplication. Which one did we mention already today? Good. Commutative multiplication. All right, so the commutative, what's the key word that goes with commutative? What's that key word? One word. Yes, order. Order. Does the order affect the product? So some of you want to multiply the two negatives together and then the positive. Fine. Some of you want to multiply the negative and the positive and then by the other negative. Fine. Whatever order you want to take is fine as long as they're being multiplied. All right. The second one is the associative. And what's the key word that goes with associative? Grouping. Whoa, you guys are quick on these. Grouping. So I can group these two together and then multiply by another, or I can group these two and these two, then multiply those two products. Fine. And for multiplication, the other two I want you to remember. Identity. What's that? What's the identity property of multiplication? Something about 1. What about 1?
Anything over times 1 is that number.
So I hope this isn't confusing. You multiply by 1. Multiplying by 1. Not x1, but multiplying by 1. Multiplying any number by 1 gives you the same number. It doesn't change the identity. And then the last one we looked at yesterday, the inverse property. And what's another word for multiplicative inverse? Chelsea? Reciprocal. That's what you need to know. Reciprocal. Okay. These are the properties of multiplication for integers. But do these apply to fractions?
No. Yeah.
Yes. Thank you for testing me out. Do these apply to decimals?
Yes.
These apply to any type of number, integer or rational, which are fractions and decimals, because they are numbers and they can also be multiplied. So yeah, these apply to all of those. Okay, reciprocal. Let me give you, just to make sure you guys get it. If I have a number a over b, what's the reciprocal of a over b? I know Nick knows. I know Chelsea knows. Parker?
B over A.
Yeah, it's b over a. So that's the reciprocal of a over b. And does anyone know what a over b times b over a equals?
1.
1. These two multiplied together give me 1. Okay, how many of you are good with these? You guys get these? We've seen them. This is the 4th time we've seen them in a lesson, maybe more. I'm going to see if you really get them. So when we're talking about the next part, I'm going to see, can you see which one of these applies to the problem I'm going to work out next, basically. All right, so here we go. Dividing, or I'll put it here, division. There's one thing I want you to know, or one main idea I want you to know with division. Remember, with multiplication, I need to know where my decimal place goes at the end of a problem. So with division, what do you think it is? The decimal place, I need to know where the decimal place is at the, not the end, but beginning. That's kind of interesting. Maybe some of you are thinking, what are you talking about at the beginning? In multiplication, my decimal point really applies at the end. Put it at the right spot based on the number of place values, decimal place values. But in division, I want to know it before I start dividing. I got to know it before. Okay, so here I'm going to give you a problem. 50 divided by 2.6. Okay, Sarah, back there, Sarah already gave me that this problem is asking me for how many groups of 2.6 are in 50. So do you guys know how many would be in 50? How many groups of 2.6 roughly would be in 50?
2.
Chloe, you're thinking.
2.5 would be 2, so pretty close.
Okay, here's what we do. Let's get some estimation here using compatible numbers. So what would you change this to divide it easily, like compatibility? Yeah, Cole? 50 divided by 2.5. Okay, you could do that. What would it be?
2. Wait, no.
Yeah, 2. I think 2 is easier. Or you could have done, yeah, 2. 2 is good. What do we get? 25? Okay. So should it be around 25? All right. Let's see if that's actually going to play, if that's going to help us with our answer. So remember the number 25. Okay. But what I'm going to do here is I'm going to work this out, and then I'm going to see if you guys know what property I'm even bringing up without me saying it. So which number always goes in the box? Always goes in the box when you're dividing. Always? The first number. But what about that one? The first number. Are you sure about the first number? Always, always, always. Which number goes in the box? The first number. All right, so here, 50 divided by 2.6. And then I just start dividing, right? Just start doing it. All right, what's my problem here? Like, what's wrong here? Yes, sir?
You have to move the decimal over 1 and then do it the same on the other side.
Okay, so do you see what I'm talking about? Decimal place at the beginning. So I'm really doing 26 into 500, or 500 divided by 26. Pause before you start working it out. How did I go from doing 50 divided by 2.6 into 500 divided by 26? Property time. You have a 1 in 4 chance of getting it right. 25%. Yes, Nick? What do you think? Yeah, he says commutative. Anyone else? Commutative.
Freaking him.
Oh my. Yeah, Rachel, what do you think?
What was the question?
So how did I go from this problem to this problem? Which property did I use? I'm using a property, I hope I am, or I'm just making something up. Wait. No, it's a property. Yes, what do you think?
Is that associative?
Okay, he says associative. Josh says associative. Do you have one? You have a 1 in 4 chance. Okay, associative. Sarah?
Maybe commutative since like we're just writing it differently because we're just like changing both.
Okay, so
Maybe switch around that.
okay, so we're gonna commutative has been removed. All right, yes. One more chance. Josh gets the second ballot. Okay, we didn't talk about distributive, but out of those 4, that's okay. That's okay. But distributive is one of those properties. All right, ready, guys? I want to figure it out. Okay, what I'm going to do, I guess I can write it up here. Can this be written as a fraction? Is this a fraction? Does anyone remember how to write as a fraction? Davis? Okay, 50 over 2.6. Now that typically we don't look at fractions that way, but that is a fraction and it is acceptable. Now watch what I'm going to do here. Ready, guys? I'm going to multiply it by something. I'm going to multiply it by a number, a special number, but not in the form it's always seen. Yeah, I'm going to multiply by 1 in the form of 10 over 10. So can I ask this, is 10 over 10 1? So it's the identity property, and you're like, wait, but what do you mean? Okay, what's 500 or 50 times 10? 500. Sorry about that. What's 2.6 times 10? Huh. So you're telling me that 50 over 2.6 is equal to to 500 over 26? Yes, because of which property? Identity property. Didn't I just multiply by a big fat 1? So I changed the way it looks. It's like I changed the clothes, but I don't change the actual value. You can change clothes, but still be the same person. Yes, ma'am.
If it was like 50 over 6 times like 1,000, would that still like
1,000 over 1,000?
Yeah.
It would still work. Yeah, and sometimes you do based on how many times you want to move this decimal. How many times did I want to move it? Once. So I multiply by 10 to the first power, which is 1 0. If it was 0.26, I want to move it how many times? So I multiply by 100, and it moves it twice, which is that whole understanding of multiplying by a power of 10. Yes, ma'am.
I tried. Oh, never mind. I get because 10 over 10 is equal to 1 because I crossed it out to make it simpler.
Oh, like
That's
simplify?
The exact same thing.
Yeah, and you end up being at the same starting point. All right, let me go to the next page. 26 into 500, okay? So you're telling me that if I do 500 divided by 26, I'm going to get the answer to 50 divided by 2.6? Yes. All right, let's do this. It's not too hard. 26 goes into 50 how many times? Once. All right, that's one time right here. That's 26. And that leaves us with 24 with a 0 brought down. 26 goes into 240. What do you think?
8 times. 9.
Okay. Oh, we have this. All right, I'm going to go in 9 just because of the way they said it. 6 times 9, 54. 18, 23. So it is going to be 9 times. 2, 3, 4 with the 6 there. Now, am I done with this division problem? Oh, that's right. It's 19 and 6, 26 is my answer, right? No. If you have a decimal problem, what kind of answer should you get?
0.6.
A decimal answer. Okay, now what is the point? Well, do you guys understand that there's a decimal point right there?
Keep going.
So yeah, you keep going. You bring down a 0. 26 goes into 60. That's 52. That's 8. Bring down a 0. 26 goes into 8. 3 times. Now, you know anything about this problem? It's going to keep going. I'm not sure, honestly, if it repeats, but it does keep going. I'm going to stop it there. On your homework, you're not going to have repeating decimal answers, okay? You will have them terminate. That means they end. So if you're, and this is what I see, and this is sad, on a quiz or a test, I'm walking by, and they're doing a division problem, and I see this paper. And I don't know if you've noticed division problems that keep going on for a long time. The division problem starts bending. So it's like bending, curving downward, and then the line gets longer. And I feel bad for them because they keep going. Am I going to do that to you today? No. Today? No, not today. I'm not actually going to do that to you any day. If your problem keeps going on and on and on and on, what do you think happened?
Yeah, wrong.
Something was wrong. So go back and see, oh man, I put 236, threw me all off. So don't go that far. Unless I say round to the nearest blank place value. Can you round this to the nearest tenth?
Yes.
What would it be? Nearest tenth? 19.2. So that would be my answer. I'm just going to take that for now. 19.2. So don't feel bad. You're not going to go infinitely out there. And if you are, something happened. Something bad happened. Okay, let's go to example number 2, and let's see how your actual problems will come out. So example number 2, we have y equals 42 divided by 0.8, and that's negative. All right, let's do a little estimation here. What do you think my answer should be in y? What did you do to get your estimation? Cole?
I think it's negative 42.
Keep going.
Wait, yeah.
You did 42 divided by, what'd you get?
1. Negative 1.
And so that gives you negative 42. So yeah, that's a good estimation. Negative 42, approximately. Is that my actual answer? No. All right, now I got to actually do it. And someone asked in the last class, I want to clarify, do we have to estimate? No. But I do that to help you out to visualize or at least anticipate an answer, and you can do it if you want to help yourself. That's your choice. Which number goes inside the box? 42 goes in the box, and outside means 0.8 output. Do I care about the negative right now? Why not? I'm done with the negative. Chelsea?
Because the negative divided by a positive equals negative.
Yeah, a positive divided by a negative is negative something. So I'm done with the negative. All right, how many times should I move the decimal? Once. Move it over. So I have my problem. And what I tend to do is I rewrite it at 8 into 420 now. Because it gets sloppy with all these arrows and things. So I'm just going to rewrite it. All right. 8 goes into 42. 5 times. It's 40. 8 goes into 20.
2.
Twice. I get 4. So I'm done, right? All right. I have to put the decimal where it belongs in the dividend and the quotient. And then I bring down a 0. 8 goes into 40.
5.
Oh, thank you. So what's my answer? Y equals negative 52.5. Negative 52.5. Let's see. Can anyone explain their answer? Just say the wording. You don't have to show me. Just say it. I think Sarah back there, Sarah Harris knows it. I know she's done it before.
Okay. Negative 0.8 goes into 42. Wait, no. Sorry. Negative 52.5 roots of negative 0.8 go into 42.
Mm-hmm. And it's tough with the negative, right? Like, what do you mean by negative? But if you ignore the negative, you would say there are 52 and a half groups of 0.8 in 52. So there are a lot of groups of 0.8 that go into 52. Or 42, excuse me. It's funny because yesterday I was tutoring after school a 4th grader. And you know what they were going over? Fractions. And I'm already thinking, I know you're in 4th grade, but you remind me of a 7th grader. Yeah. So, what? Is it offensive? No, I'm just saying, this stuff that you're doing, they're doing. Like, let's get it down. Let's not as deep. He's not multiplying or dividing or anything, but he is thinking of fractions, and I want him to think about it well then, and then he can get it down when he comes to you guys, your group. Boy. I don't know if I should share that. All right. That's what I call him. Hey, boy. I think actually, boy. I've heard it on like movies, like a guy call a son boy. Boy, get over here. I think. No, I don't mind. Sorry, their actual name was not boy. It's just he calls him boy. Like, you're a boy, boy. So I think I've done that to Ezra a couple times. Boy, come over here. Oh my. All right. This is example 4. Last example, and then I'll let you go. All right, on these problems, these are called evaluation problems because you're trying to find out what is the value of this when m equals 0.5 and n equals negative 3.2. All right, so what I do, my first step, like I've done previously, is just put the numbers where they belong. 6 times 0.5 divided by negative 3.2. All right, so order of operations says I should do what first? Okay, do parentheses. Is there anything to do in there? Nope. But then you do the, what's technically the next step? Exponents. No exponents? We're done with that. So then you go to multiplication division, and you're going to do this multiplication first. What's 6 times 0.5?
3.
Okay, it's 3. What's cool about it, some of you just know that, which is cool. But I can ignore that decimal point. What's 6 times 5? Just 6 times 5, 30. And then how many decimal place values were there? So you move it over once, it becomes 3. That's how I got 3 from that. All right, which one goes in the box? The 3. Which means 3.2 goes outside. My answer, positive or negative?
Negative.
Wow, that was quick. Okay, so it's going to be negative something. So I don't even think about the negative anymore. You guys good on this? Do it. You guys said yeah, so okay.
I didn't say yeah.
Oh, oops. Yeah, try it out. Try your best here. Get me an answer. Go slowly, Work carefully and write neatly. I know, 3 steps to success. Slowly, neatly, carefully. Or is it carefully, slowly, neatly? I think it's neatly, slowly, carefully. Slowly, carefully, neatly. That's it. Will this go on forever? No. Please, if it's going on for a long time, you've done something, you've gone too far. How many times does 32 go into 300? Maybe a little a little boost will help you out. How many do you think? Just guess, it's okay. 9 times. Goes into it 9 times. 9 times 32 is 288. So that gives you a remainder of 12, 120. All right, you can keep going. All right, does anyone have the next digit? 0.93. 32 times 3 was 96. If this were Mr. A's paper, like he's at the bottom right of his paper, you think it's going to go well?
No, it's not.
No, so what do I have to do? Shorthand, yeah. Anyone do it shorthand? Like short division? You could do that. But if I'm here, I'm like stuck, I can just squeeze it all in there, right? And that's what I meant by the curviness. People start working it this way. It starts working like that. Like, what are you guys doing? You need to make sure you had a good starting point, so don't start it at the end to where you're not going to get to this point. And then, thankfully, you guys have paper that is long, unlike my board. Next digit, anyone get it? 7. So far, so good. One more. Excuse me? You sure? Oh.
It is. Definitely. Yes, it is.
Yeah, I do that, Sarah. You almost made it. You almost made it through the eye test. Negative 0.9375. Was that a tough problem? Was it tough? Yeah. So this, division, I think is going to be tough. I shortened the homework because I didn't want to give you too much. But I would say this, just be careful, write neatly, and go slowly. Don't go fast and then sloppy, and then you're just making all these little mistakes, and you don't even know it. That's the sad part. But every paper should have work when I get it tomorrow. If you just have the answer 0.9375, whatever it was, I'm like, how'd you get that? It's on another paper. No, it's on the paper you turn into me. Don't just look at the back. Get the answer and you're done. I need work. Is that hard? Yes, but that's okay. Yes, ma'am?
So, what was I going to do? Oh, yeah. Wait, no. Oh, yeah, are we tomorrow to, review for our quiz? Are we going to have a big homework? Because we have a day.
I'll be there.
So you don't have to.
I do homework behind this. No. I'll tell you what we're doing tomorrow because you do have a quiz on Friday.
Thank you.
That's good. So you're good now?
Mm-hmm.
Good. All right.
Oh, yeah.
He hasn't wrote the page yet.
Oh, that's right. Oh, my. Page 298. Yeah, I just took out those review problems. Yeah, get to work. You have a few minutes to work on that by Swivl.